Good morning everyone. I am Mary Sjctnc-C.Mary, guest lecturer, PG and Research Department of Computer Science, St.Joseph's College of Arts and Science, Cuddalore. In this video, I am going to discuss with you about satellite communications. First, let's see what is satellite. In general terms, a satellite is a smaller object that revolves around a large object in space. Satellite is a smaller object that revolves around a larger object like Earth in space. For example, a moon is a natural satellite of Earth. Next, let's see what is communication. Communication refers to the exchange or sharing of information between two or more entities through any medium or channel. In other words, it is nothing but sending or receiving and processing of information is called communication. If the communication takes place between any two earth stations through a satellite, then it is called as satellite communication. That is, if the communication is taking place between any two earth stations through satellite, means it is called as satellite communication. In this communication, electromagnetic waves are used as carrier signals. These signals carry the information such as voice, audio, video, or any other data between ground and space or from space to the ground. Next is need of satellite communication. Satellite provides communication for long distances, which is well beyond the line of sight. This is the most important need of satellite communication. Using satellite communication, we can provide communication for long distances, which is well beyond the line of sight. Since the satellites locate at certain height above Earth, the communication takes place between any two Earth stations easily through satellite. So, it overcomes the limitation of communication between two Earth stations due to Earth's curvature. A satellite is a body that moves around another body in a particular path. A satellite is a body that moves around another body in a particular path. A communication satellite is nothing but a microwave repeater station in space. It is helpful in telecommunications, radio and television along with internet applications. The frequency with which the signal is sent into the space is called as uplink frequency. Uplink frequency is nothing but the frequency with which the signal is sent into the space from Earth station. Similarly, the frequency with which the signal is sent by the transponder is called as downlink frequency. The following figure can explain this concept clearly. See here, this is the uplink frequency. This is the frequency where the signal is sent from the Earth station to the satellite, and the downlink frequency is the frequency where the signal is sent from the satellite to the Earth station. A repeater is a circuit which increases the strength of the received signal and transmits it. But this repeater works as a transponder. This is in the transponder is an electronics which is in the satellite to convert the uplink signal into the downlink signal. Transponder is the electronic circuit which is present in the satellite that converts the uplink signal into the downlink signal. So, the important terms we have to remember is uplink frequency, what is uplink frequency, what is downlink frequency, what is the work of the transponder, everything we should understand. Next is classification of satellite orbits. Based on the orbit, there are two types of classification. One is circular orbit, another one is the elliptical orbit. Satellites in circular orbits always keeps the same distance to the Earth's surface. If the satellite rotates in the circular orbit, means it always maintains the same distance to the surface of the Earth. In an elliptical orbit, it is in the shape of an ellipse. In an elliptical orbit, the satellite's velocity changes depending on where it is in the orbital path. That is, if the satellite is here, means it is very nearer to Earth. If the satellite is here, means it is furthest distance from the Earth. This point is known as apogee. Apogee means the satellite is furthest from the Earth. When the satellite is furthest from the Earth, it is called as apogee. When the satellite is nearest to the Earth, means it is known as perigee. Next, let's see about classification of orbits. Classification of orbits based on the height of the satellite. The orbits are divided into three types. First is geostationary orbit, medium Earth orbit, that is MEO, and low Earth orbit, that is LEO. Geostationary orbit is shortly known as GEO, and medium Earth orbit is shortly known as MEO, and low Earth orbit is shortly known as LEO, LEO. Let's see in this diagram. Earth is in the center. Above the Earth, the first orbit is known as lower Earth orbit, LEO, and the second orbit is known as MEO, medium Earth orbit, and the outermost orbit is known as GEO, that is geostationary orbit. Let's discuss about these orbits in detail. Let's see about the advantages and disadvantages of each orbit. First, let's see about geostationary Earth orbit satellites. Geostationary Earth orbit satellites are synchronous with respect to Earth. That is, it rotates with the same speed as Earth. Looking from a fixed point from Earth, these satellites appear to be stationary. So it has 24 hours view of particular area. That is, the satellite in the geostationary orbit can be viewed for 24 hours. Then next point is the satellite should be placed 37,786 kilometers distance above the surface of the Earth. That is, the distance of the satellite from the Earth is 37,786 kilometers. Next, these satellites are placed in the space in such a way that only 3 satellites are sufficient to provide connection throughout the surface of the Earth. That is, since the geostationary orbit is very much distance, that is 37,000 kilometers away from the Earth, using 3 satellites, the whole Earth can be covered. The orbit of these satellites is circular. Lifetime expectancy of this satellite is 15 years. The satellites in the geostationary orbit has the lifetime of 15 years. Next is disadvantages of geostationary orbit. That is, northern or southern regions of the Earth have more problems receiving these satellites due to the low elevation above a latitude of 60 degrees. So larger antennas are needed in this case. This is the disadvantages of geostationary orbit. Next, the gravitational pull of Sun and Moon makes these satellites deviate from the orbit. Next, Shading of signals is seen in cities due to high buildings and the low elevation further away from the equator limit transmission quality. So the transmission quality is limited. The transmit power needed is relatively high, which causes problems for battery powered devices. Since the distance is 37,000 km from the earth, the transmission power also needed relatively high. Next, these satellites cannot be used for smaller mobile phones. The biggest problem for voice and also data communication is the high latency. So these are the disadvantages of geostationary orbit. Next, let's see about medium Earth orbit, that is MEO satellites. MEOs can be positioned somewhere between LEOs and GEOs. Because it is a medium Earth orbit, it is between LEO and GEO, both in terms of their orbit and due to their advantages and disadvantages. Using orbits around 10,000 km, the system only requires a dozen satellites, which is more than a GEO system but much less than a LEO system. These satellites are at the height of 10,000 km away from the surface of the earth. So, in order to cover the whole earth region, it requires a dozen satellites. Dozen means 12 satellites. Using 12 satellites, it can cover the whole earth. These satellites move more slowly relative to the earth's rotation, allowing a simpler system design. This satellite rotates slower than the Earth's rotation. Satellite periods are about 6 hours for MEO satellite. That is, the visible time of GEO satellites are 24 hours. The visible time of MEO satellites are about 6 hours only. Depending on the inclination, a MEO can cover larger population, so requiring fewer handovers. Next is disadvantages of MEO. Again, due to the larger distance to the earth, delay increases to about 70 to 80 milliseconds. Next, the satellites need higher transmit power and special antennas for smaller footprints. Like GEO satellites, MEO also require higher transmit power. Next is latency is typically higher than LEO and lower than GEO, while data rates for a given antenna size is higher than GEO and lower than LEO. So, for a given footprint or quasi-global coverage, you will need more satellites than GEO but fewer than LEO. It requires more satellites than GEO and lesser satellites than LEO. Next, let's see about LEO satellites, lower Earth orbit satellites. These satellites are placed 500 to 1500 kilometers above the surface of the Earth. As LEOs circulate on the lower orbit, they exhibit a much shorter period, that is 95 to 120 minutes. That is, the visible time of GEO satellites are 24 hours. The visible time of MEO satellites are 6 hours. But the visible time of LEO satellites are only 95 to 120 minutes only. Then each LEO satellite will be only visible from the Earth for around 10 minutes. LEO signal is much stronger than GEO signal, using low transmit power in the range of 1 watts. Since the distance from the Earth to the LEO satellites are very low, that is only 500 to 1500 kilometers, the transmit power is also less. 1 watt is enough to transmit power. The delay for packets delivered via LEO is relatively low. The delay also very low. The delay for packets is also very low compared to the GEO and MEO satellites. The next is disadvantages of LEO. The biggest problem of LEO concept is need for many satellites if global coverage is to be reached. Using GEO satellites, only 3 satellites is enough to cover the whole Earth. In MEO satellites, dozen satellites is enough to cover the whole area. But for LEO satellites, it needs more satellites than GEO and MEO to cover the whole Earth. Around 50 to 200 satellites it needs. Next, the high number of satellites combined with the fast movements resulting in a high complexity of the whole satellite system. Also, another problem is that short lifetime of about 5 to 8 years due to atmospheric drag and radiation from the inner Van Allen belt 1. Due to this problem, the lifetime of the LEO satellite is very short, for about 5 to 8 years only. These are the comparison of GEO, MEO and LEO satellites. The full form of GEO is Geostationary Earth Orbit Satellite. Full form of MEO is Medium Earth Orbit Satellite. Full form of LEO is Low Earth Orbit Satellite. So the orbital period is 24 hours, 2 to 8 hours, 10 to 40 minutes. The height is 35,800 km, 5,000 to 12,000 km, 500 to 1,500 km. Satellite life is long, short. And propagation losses, this is the highest loss, high, least. Number of satellites required to cover the whole Earth is 3 satellites, 8 to 20 satellites, 40 to 80 satellites. And the advantages are, it covers larger graphical area with only 3 satellites. It covers a larger area with 8 to 20 satellites. It requires 40 to 80 satellites to cover the whole area, whole Earth. It is visible for 24 hours. It is visible for less time compared to GEO, and it is visible for only very much less time. Then it is ideal for satellite broadcast and multi-point communication. Next, it is a weaker signal compared to LEO. It is a very large number of satellites network is required, thus it is very costly. And the disadvantage is, it is above the equator. It faces difficulty in broadcasting near polar region. Visible for only 2 to 8 hours. Atmospheric drag effects are more, which cause gradual orbital disorientation. It is visible only for 15 to 20 minutes from a particular area. Thank you.